All right, let's talk about section 8.3. First definition that we're going to look at here is called population mean, and that is just the average of a survey sample. All right, it's a survey of the entire population. Now, most of the time, the population mean is really hard to get a hold of because if the population is everyone in the state of Michigan, for example, you can't usually survey every person in the state of Michigan. The way that is, so usually we are working from just a sample, okay? So the population mean is just the average from a sample survey, again, because it's so hard to get the, in many instances, the entire population average of whatever we're trying to analyze, okay? So the population mean is denoted by this Greek letter lowercase mu, and it's equal to the sum, this is Greek letter sigma, the sum of all of the x values. So you don't necessarily need to remember the notation here, but you'll see it in the book, and it does have some meaning. So this means the sum of all of the x values divided by n, which is the number of x values. So just write this off to the side. This is this here is the sum of all x values, and then n is the number of values, the number of x values. All right, and then from there, we're going to talk about population proportion. The population proportion is just the proportion of the population that has a particular trait, okay? So we'll do some examples here in a second, but the example that we're going to do looks at the number of siblings from 20 different students, how many siblings they have. And so if one of the questions we could ask is what proportion of students had 0 siblings, okay? And then that would just be the fraction of students that had 0 siblings, okay? So, let's go right on to that. So what is the population mean for the number of siblings? Let's start with that. The population mean is, if we've surveyed 20 students, you can see the data off to the right. 3 students had 0 siblings, 8 students had 1 sibling, 5 students had 2 siblings, and so on. That's how this chart is read. Okay, this sum of all of this right here is 20, if you add all of these up, because there was 20 people surveyed. All right, and so what we want to know is what is the population mean. So we'll figure out what mu is. It's just going to be, now there's a couple of ways that we could do this. There's 3 data points that have a value of 0, right? 3 students had 0 siblings, so we could do 0 plus 0 plus 0, and then we could do 1 plus 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 1 8 times, and then 5 2s, and so on. Or we could just use multiplication. So the sum of all of these is going to be 0 times 3 plus 1 times 8 plus 2 times 5 plus 3 times 2 plus 4 times 1 plus 4 times 1. Sorry, 5 times 1. Okay, that's all divided by 20, and that'll give you the average. Again, you could add this, right? You could do 1 plus 1 plus 1 plus 1 8 times, but this just saves us a little bit of time. So the mean then is going to be equal to, I don't need to show you the typing of this into the calculator. It ends up being 1.65 is the average number of siblings that the students have. Okay. What is the population proportion of students who have 1 sibling? Okay, so now we want to go to figure out what fraction of the 20 students had 1 sibling. There are 8 of those students, and so it will be 8 over 20. And usually we denote, when we're trying to find the population proportion, we just denote it by P. So the proportion we're trying to find is 8 over 20. This ends up being 2 over 5, or 0.4, sorry, 0.4, or 40%. Okay, and yeah, so one other thing just to mention here, this is the number of students with 1 sibling, that's where that came from, and 20, which is total population. You might write that down. Okay. All right, last thing we're going to talk about is called margin of error. Okay, and so we have a formula for margin of error. It is just this, all margin of error is the accuracy of a sample survey. And so it gives us an idea of how accurate the survey is based on how big the sample is. The bigger the survey, the bigger the sample, the smaller the margin of error. In other words, the data is more reliable the more people that are surveyed, or the more things that you have in the data set that you're analyzing. Okay, so this determines how reliable the survey is. The larger the sample size, the smaller the margin of error. All right, here's the formula. It is just plus or minus 1 over the square root of n times 100, and n is just the sample size. Okay, so let's put this to use here. So a survey of 600 people was conducted that showed 55% plan to vote for the incumbent candidate. Okay, we want to find the margin of error. So this is n, and then we're just going to put this into the formula. So we're going to find the margin of error and the percentage range. Okay, so here's the margin of error. It's just equal to plus or minus 1 divided by the square root of n, which is 600, times 100. And that timesing by 100 just gives us the percent, right? Otherwise, this is going to come out as a decimal. So that turns it into a percent. So let's do that real quick. 1 divided by the square root of 600. Okay, times that by 100. That gives us a margin of error of about 4%. So this will end up being plus or minus 4. Okay, so then to get the range, then the range of people that, or the range of the percentages shows we've got 55% plan to vote for the incumbent candidate. Well, that's good. That could be off in either direction by plus or minus 4%. So the range is going to be from 51% to 55 plus 4, so that was 55 minus 4, up to 55 plus 4, which is 59%. All right. So you can also use this formula in reverse. So what you can do is take, if you've got a margin of error, you can work it back to figure out what the sample size was. And so what we'll do is we'll take this 8, all right, and we'll plug it into the formula as our margin of error up here. So we have 8 plus or minus 8, I guess. Plus or minus 8 is equal to plus or minus 1 over the square root of n, which we don't know, times 100. All right. And then we're just going to try to solve for n here. And so what we'll do is divide both sides by 100. So on the left we get plus or minus 0.08. And actually, in fact, we don't need the plus or minus because it shows up on each side. So we can just drop the plus or minus. All right, so 8 over 100 is just 0.08. That's going to be equal to 1 over the square root of n. And then we're going to times those sides by square root of n. So I get 0.08 times the square root of n on the left is equal to 1 on the right. Continuing on here over to the right. Then I'm trying to get n by itself, so I'm going to divide both sides by 0.08. All right, that'll give me 12.5, so the square root of n is equal to 12.5. And then when you square both sides, you get 12.5 squared, which turns out to be n is 156.25, or about 156 respondents. Okay, and so that's how that formula works. You can kind of use it going in either direction, either given the margin of error or just given n to figure out the margin of error. And that's really all there is in section 8.3.